In Greece, a seismic crisis involving a total of more than 15,300 earthquakes between the islands of Santorini and Amorgos is now in its 27th day. With the vast majority of locals now having left the fantastic island of Santorini, and with 4 islands having a state of emergency, you'd hope that by now us scientists would truly know what is ongoing here. As you might have noticed, ignoring the nonsensical doom and gloom types which there is no basis for, us geologists, seismologists, and volcanologists are currently divided into 2 camps to explain why such an absurdly strong and long-duration swarm is occurring. On one hand, we have people that think the earthquake swarm is primarily tectonic, and on the other hand we have people that think this is primarily volcanic. Any of these possibilities are still quite plausible, hence the confusion from scientists disagreeing with one another. This is why us scientists are all building off of what seems to be the best working hypothesis on any given day and adding variations to try and slightly better explain this strange ongoing situation. And, as more data has arrived, some of our opinions have shifted somewhat 4 times now. I will now be building off of a particularly new intriguing hypothesis made by Dr. Judith Hubbard and Dr. Kyle Bradley with some changes of my own, with their original hypothesis originating in a fine article on their Substack, link in the description, which you should definitely read by the way. The modified theory is as follows. Since the summer of 2024, a weak magmatic intrusion has been ongoing at the Santorini volcano underneath the island of Nea Kamenni, causing minor amounts of uplift as molten rock ascended from its deeper massive magma reservoir at 9 to 15 kilometers depth, to the very bottom of its 4 to 6.5 kilometer depth magma chamber. This is involving such a negligible volume of magma that it can't cause an eruption within the islands of Santorini at this time or in the near future. However, something changed around January 24th of 2025. It appears that a dike intrusion of magma at somewhere between 9 and 15 kilometers depth began propagating northeastwards beyond what we thought was the known boundary of the Santorini volcano. Since much of this magma intrusion was initially centered in the ductile portion of the regional crust, this expanding dike initially did not produce many earthquakes. As molten rock in this magma dike passed by the Colombo submarine volcano, it generated volcanic tremor which was detected, alongside secondary earthquakes. These Colombo quakes then subsided, but as molten rock progressed further northeastwards it generated an increasing number of small magnitude earthquakes which did not rise above magnitude 3.2 at the top of the dike at 9 to 13 kilometers depth. Then, late on January 31st, the nature of the earthquake swarm, larger earthquake cores, changed as the deep magma drove hot fluids which were primarily water but also carbon dioxide from said magma, and nearby heated surrounding rocks upwards to shallower depths. These fluids began interacting with the various large-scale normal faults in the region, which represented paths of least resistance. As these fluids moved into the faults, they in essence made them more slippery, decreasing the friction between the 2 sides of the fault, allowing them to more easily slip, thus causing repeated larger magnitude earthquakes to occur, including magnitude 4 and 5 events. The aforementioned dike still continued to expand during this time via magma that did not represent a continuous influx but arrived in pulses. One of these batches arrived between February 1st and 5th, and a second batch arrived between February 7th and 11th, causing the existing dike to expand during each of these 5-day-long episodes further northeastwards, which is reflected by the average location of earthquakes during those periods. If this magma dike does exist, it would perfectly explain why, since the earthquake swarm began, the very slow uplift at Santorini turned into more rapid but still slow subsidence, while at the same time the island of Enidros began uplifting. Throughout all of this activity, there may have been brief moments where magma-modeled magma dike statistics indeed did rapidly advance upwards, but then again the apparent tremor this triggered could have just been non-magma fluid movement. We aren't exactly sure. However, if this tremor was caused by magma movement, said magma still seems far too deep and is occurring for far too little of a time to create a high or even moderate chance of a volcanic eruption happening. In other words, at this time, I am not expecting any form of submarine or aerial eruption in the near future here. However, this model has a potential problem, which possible model problems I will outline with the text being displayed here. Thankfully, the rate of earthquakes has halved since its peak on February 3rd but has remained fairly constant during the past 5 days. The good news is that the rate of magnitude 4 and larger quakes and remained quite low. Stay tuned for more updates. As a final note, I would like to thank my new YouTube channel member Steve Whalen for supporting my work. English.